Good morning, students. Welcome to lecture 3 of module 3 operational amplifiers. We'll see the remaining parameter definitions. So, slew rate is given by the ratio of change of output with respect to simultaneous change in input. So, it is denoted by S. Ideal value is infinity and practical value is zero point 0.5 volt per microsecond, and it is calculated using this particular formula where you can see why the particular unit is 0 0.5 volt per microsecond. The change in output voltage with respect to the time where you are seeing how fast your output will change for a simultaneous change in your input. Yeah. Ahead, you've already seen input bias current. Now we'll move into the next parameter, that is power supply rejection ratio. So we know that we have two power supplies, that is plus VCC and minus VEE. So here for the power supply rejection ratio, it is defined as the ratio of change in the input offset voltage due to the change in the supply voltage producing it, keeping the other power supply constant. So if there is a change in your input offset voltage because of the change in the positive power supply, we keep the negative power supply constant. So power supply rejection ratio is change in input offset voltage with respect to the change of the positive power supply, keeping the negative power supply constant. We can do the other way also, where the power supply rejection ratio is the change in input offset voltage to the change in the negative power supply, keeping the positive power supply constant. Ideal value is 0 and practical value is 30 microvolt per volt. So the unit here is 30 microvolt per volt. Clear? So moving forward, so let us see the first application of the operational amplifier, the most simplest one, that is the voltage follower. Now, a circuit in which the output voltage follows the input voltage is known as voltage follower, right? And we have already seen the concept of virtual ground. So here, first I need to see what is the voltage across point B. So since node B is connected to V in, so VB will be equivalent to V in, and by virtual ground VB is equivalent to VA, which is equivalent to V in. So by virtual ground VB equal to VA, which is equivalent to V in. So, and you can see in the particular circuit where node A is directly connected to the output. So your output voltage V naught will be same as the voltage across point A. Clear? So which indicates that V out is equivalent to V in. So that is what is the definition of the particular circuit, that your output voltage will follow your input voltage. Now what will be the gain of this particular voltage follower? So voltage follower gain is given by output by input. Since both output and input are same, the gain of the voltage follower is equal to 1. So voltage follower is a circuit whose output follows the input voltage. So if you have a circuit like this, whatever is your input voltage will be the same appearing across the output voltage. So let us take an example. If I give input voltage to be 10 volts, my output voltage of this particular circuit is also going to be 10 volts, because the gain with which it is going to multiply the output is 1. So output voltage will be gain, that is 1 into the input voltage. So output voltage 1 into whatever is your input voltage is the same that is going to appear. So your output voltage is going to be equal to your input voltage in a voltage follower. So thank you. So let us conclude this particular lecture, and we will see the furthermore applications in the next video. Thank you.